This is the review for the semester exam, second semester exam, and I'm going to go ahead and do number 1. A ball is thrown in the air. The relationship between the amount of time the ball is in the air, seconds t, and the ball's distance above the ground is represented by this equation. How many seconds will it take to hit, or for the ball to hit the ground? So I'm going to go ahead and use the calculator. And you notice I'm using x instead of t, but it's going to represent. You might have to change the window. So I'm going to go to the window. And I'm going to change the window settings, and X max, I'm probably going to make it Y max. I'm going to say 30. Let's see what happens. Okay, so remember that the Y is representing the height, and it says how many seconds will it take for the ball to hit the ground. Well, it starts at 0, and then we need to know when it goes back to the ground after so many seconds. I'm going to go ahead and press tab and put 0. And you notice I have y equals 0, and then I have the graph. So now I just have to find the intersection. So that's what I'm looking for. Analyze graph. Intersection. So here is the lower bound, upper bound. And so after 2 seconds, the ball will hit the ground again. So the answer is C. If you want to check it differently, all you can do is you can substitute. We have negative 16. And then we have 2 squared plus 30 times 2 plus 4. When you type that into the equation editor, which I'm going to do right now, you're going to notice that it's going to be equal to 0. Negative 16 parentheses 2 squared plus 32, 4, enter. I put negative 13. I don't know why I did that. Negative 16 parentheses 2 squared plus 32 plus 4. Number 3, what value of x is the solution to this equation? So we have 10 plus the square root of x minus 1 equals 12. Our first step is to subtract 10 from both sides. So you have square root of x minus 1 equals 2. And since it's a radical, we're going to square the left and then square the right. So when you square a radical, remember that the index is 2. So we know that those two are going to cancel. So we have 2 squared, which is 4. X equals 5. Now you notice that I've typed in this equation into the calculator. I went ahead and substituted x for 5. And if it's correct, it should be equal to 12, and it is. Number 5, what value of x will make the following equation true? We're dealing with logarithms. Remember that x is a base, so you would write x. You know that negative 4 is the exponent, and we know that that's going to be equal to 81. So what I have is I have 1 over x to the 4th is equal to 81. So what I'm going to do is I have 81 divided by 1. So I need to know the value of x when it's raised to the 4th power is equal to 81. So here's a strategy. We're going to get the 4th root of the left side. You're going to get the 4th root of the right side. Go to your calculator, control, and then you have this symbol. And remember the index is 4. And we want to get the 4th root of 81, which gives us 3. So we have 1 over x is equal to 3. So we have 1 is equal to 3x. So x is equal to 1/3, since I have to divide by 3. For me to check this, I would just have to substitute x equals 1/3 into the logarithm. So the log base of 1/3 of 81 is equal to negative 4, and it does check. For number 7, what is the value of x when the equation 4 equals log base 3 of x? What you need to do is you need to write the inverse. You need to identify the base, which is 3. You need to identify the exponent, which is 4. And then we have x. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So if you want to check, we need to go ahead and substitute the value of 81 in for x. So I'm going to go ahead and do that and show that in the calculator. Okay, you can see that. I'm going to go ahead and press enter. And you notice it does match our answer. So we did do it correctly. Number 9, what is the solution to the equation log? And of course we know that's base 10 of x minus 2 plus log base 10 of x minus 5 equals 1. We know that the property that is called the product property will allow us to do this. So we have log x minus 2 x minus 5 equals 1. So we're able to do that because of the log property of the product. And then so what we're going to do is we're going to convert it to its inverse. So we have 10 to the first because that's base 10. And then we're going to multiply x minus 2 times x minus 5. So you have 10 is equal to, and we're going to use the FOIL method. So we have x squared, and then you have negative 5x because it's x times negative 5. Negative 2 times x gives you negative 2x. Negative 2 times negative 5 gives you plus 10. So you have 10 equals x squared minus 5x minus 2x gives you minus 7x plus 10. We subtract both sides, so we have 0 is equal to x squared minus 7x. We find the greatest common factor. What do they have in common? And they have x in common, so we have x minus 7. So one of the answers is x equals 0. The other answer is x equals 7. So your answer is C. If you look on the screen here, we have log base 10 of 7 minus 2 plus log base 10 of 7 minus 5. And we want it to equal 1, and it does equal to 1, so the answer does check. Number 11, which of the following is a solution to the equation log? So it's log base 10 of x squared equals 2. Well, you can always move the 2 to the front, so you have 2 log base x is equal to 2. The next step is to divide by 2. So we have log base 10 of x equals 1. And when we convert it to the inverse, it's going to be 10 to the power 1 is equal to x. So x is equal to 10. So that's our answer. Now we can check this. So we're going to type in control log, of course it's base 10. And we know that it's going to be 10. And we're going to raise it to the second power. And you notice, it does come out to 1. Number 15, when factored completely, this equation is equivalent to which of the following expressions? So you know that you have 4a cubed plus 4a squared minus 48. They're all divisible by 4, so you can factor a 4, and we do have an a here, and you can also factor an a. So you're left with a squared plus a minus 12. Remember, when factoring minus 12, it's going to be 4a parentheses, so the factors of negative 12 are negative 2 and 6, negative 3 and 4, and you're adding. And we're looking for the middle coefficient, which will be negative 3 and 4. So you have a minus 3 and we have a plus 4. So your answer will be 4a and you have a minus 3 times a plus 4, so your answer is C. 17, which expression is equivalent to, and we have y cubed minus 2y squared plus y. You look for what they have in common. In this case, you have a y that's in common, so you have y squared minus 2y plus 1. Find the factors of 1 that are going to give you negative 2. Well, definitely negative 1 times negative 1 gives you negative 2 when you add both. So you have y, parentheses, y minus 1, y minus 1. So your answer is B. Which expression is equivalent to the factored form x squared minus y squared? That's a difference of squares. And we've already talked about this formula many times in class. X squared minus y squared is equal to x minus y, x plus y. So your answer is B. Remember, that's the formula, a minus b times a plus b. 21, we're going to find the greatest common factor. What is it? What is 2x cubed minus 13x squared plus 6x in factored form? And you notice they have an x in common. So it's 2x squared minus 13x plus 6. Remember the way I taught you, you're going to multiply 2 times 6. So you have x is equal to x squared, you drop the 2, minus 13x plus 12. Find the factors of 12. So you have x minus 12, x minus 1. And then you're going to bring in the 2 again. So you have x times x minus 6. And you're going to kick up the 2, so it's going to be 2x minus 1. So your answer is A. Number 23, what is 2t to the third power plus 8t squared minus 24t in factored form? So we have 2t to the third power plus 8t squared minus 24t. You can factor a 2. You can factor a t, so you're left with t squared plus 4t minus 12. So you have 2t, and then the factors of negative 12 are negative 6 and 2, 6 and negative 2, and you're going to use 6 and negative 2, t minus 2, and then t plus 6. So the answer to this will be A. (25), which is equivalent to 7y parentheses y minus 2z minus 3y times 2y plus z. So you're going to use the distributive property. So you have 7y squared minus 14yz minus 6y squared minus 3yz. 7y squared minus 6y squared is just y squared. Minus 14yz minus 3yz is negative 17yz. So your answer is C. 27. Which expression is equivalent to the ones below? So we have x to the third power plus 4x minus 3. Distribute the negative, negative x cubed plus 2x minus 5. X cubed minus x cubed is 0. 4x plus 2x is 6x. Negative 3 minus 5 gives you minus 8. So your answer is C. The graph of f of x equals x cubed is shown below if the function is changed to x cubed plus 5, which
graph depicts a transformed function. Let's go ahead and graph. So we have the parent function, x cubed. And of course, we have the new function is changed to x cubed plus 5. And I know you guys know your transformation rules. Plus 5 means that the graph will go up 5 units. So your answer is not going to go. It's not going to go to the right. It's not going to go to the left. Your answer is B. Okay, for this problem, we're dealing with transformations. This is the next section. We're dealing with transformations. How will the graph f of x change if the function is changed to -5 cube root of x? So I'm going to type in the other function, -5 cube root of x. Now remember, we've been talking about transformations. The negative will reflect it over an axis and the 5 will stretch. And it will stretch horizontally? Nope. It will stretch vertically? Yes. Stretch vertically? Yes. Reflected over the x-axis? And the answer is B. It's going to stretch by a factor of 5 and then be reflected about the x-axis. The cube root function f of x is transformed to this cube root function plus 6. So the 6, if I just put plus 6, you know it's going to do what? Yep, it's going to go up. It's going to go up 6. Your answer is A. So yeah, remember, if it's -6, it's going to go down. If it's -6 inside the radical, it goes to the right. And if it's plus 6, it goes to the left. Inside. For number 35, we are going to factor. Remember, this is a difference of cubes. So we have parentheses 3p to the third power minus 2 q to the third power. How did I get that? Well, you know that 3 to the third power is 27. And we know that 2 to the third power is 8. And this is just a formula. So we have 3p minus 2q. You're going to get the first term. So it's going to be 3p to the second power, which is going to give us, remember, 3 is going to be squared. So it's 9p squared plus, you're going to multiply 3p and 2q. And so you're going to get times 2. And so it's going to be 3 times 2, which gives us 6. So it's going to be 6pq. And then the last term, it's going to be -2q to the second power. So that's going to be 4q squared plus. So your answer should be not A, and nor B and C. So your answer should be D, because it's going to be 3p minus 2q, and you have 9p squared plus 6pq plus 4q squared. When factored completely, 27x cubed minus 8y cubed is equivalent. Well, I'm going to rewrite this, and I'm going to rewrite it as 3x to the third power minus 2y to the third power. And I know the formula is 3x minus 2y, parentheses, you get the first term and you square it, which is 9x squared. You multiply 3x and 2y plus 6xy, and then you add the square of the last term, which is 2y, to the second power, which is 4y squared. So it's going to be D. We're going to go ahead and simplify radicals. You know that 144 is the same thing as saying 12 squared. So we have the square root of 12 squared, and then we have m to the 6th. Now we do know that the index is 2, and we do have 12 times 12, and that does form a group of 2. So the square root of 144 is 12. So we're going to put 12 on the outside of the radical. M to the 6 is m times m times m times m. Now you notice this is right here. That's one group of m. So the square root of m squared is just m. M times m is m squared. This is another set. And the square root of m squared is m. Now we didn't have 4, we had 6. So m times m. The square root of m squared is m. So what does it finally simplifies to? 12 times m to the 3rd power. So your answer is C. From our last example, we know that the square root of 144 times x to the 16 is going to equal the square root of 12 squared, and then we have x to the 16th power. We know that the index is 2, and so when we get the square root of 12 squared, it's just simply 12. 16 is even, and I want to make sure that I can make groups of 2. So if I just divide 16 by 2, that tells me I can make 8 groups. So it's going to be x to the 8th power, so your answer is B. In other words, if I had x times x times x times x, so that's 1 group, that's 2 groups, that's 3 groups, that's 4 groups. Now you notice we have 4 groups and we have 8. X times 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 x. This is x to the 8th. And then if we do it again, we have x times x, x times x, x times x, x times x. So we have x to the 16th. So we could make 4 groups in the first row, 4 groups in the second row. That's why it simplifies 12 times x to the 8th. Or you can just divide 16 by 2 and that gives you 8. And you know that 12 squared is 144. The square root of 144 is 12. 49. Which expression is equivalent in lowest terms? So we have the square root, and we know 16 is for squared, x to the 8th, we have y to the 13th, and z to the 10th. Now, when we get the square root of 16, we notice that it's going to be 2. X to the 8th, we have x times x times, we have 8 x times x times x times x, x times x times x times x. So we want groups of 2 since the index is 2. That's the square root of x squared is x, the square root of x squared is x, the square root of x squared is x, the square root of x squared is x. So it's just simply 8 divided by 2 gives you 4 groups. So we have x to the 4th. Now, y to the 13th is a number that is not divisible by 13, but 12 is. And if we had 13 y's, so that's 1 group, that's a 2nd group, and that's a 3rd group, and then we have y times y, and that's a 4th group. So that's 2, 4, 6, 8, 10, 12, 13. So you notice we have an extra y, but we can make 1, 2, 3, 4, 5, 6. We can make 6 groups, but we're gonna have an extra y. So the dilemma is, what do we do with that extra y? We're gonna have to leave it in the radical. We have to leave it in the radical. Now z's, we have 10 z's, and if we're going to group them in 2's, we know that we're going to be able to make 5 groups. So what does this simplify to? 4 squared. Oh, yeah, it's going to be 4. The square root of 4 squared is 4. So it's going to be 4x to the 4th, y to the 6th, z to the 5th, times the square root of y. Which expression is equivalent, and we have the third root of 32x over the third root of 4. So what I'm going to do to make my life easier, I'm going to say the third root of 32x over 4. So the third root of 32x over 4 is actually 8x. Now, 8 is interesting because 2 times 2 times 2, which is actually the same as saying 2 to the third, the cube root of 8 is 2. Unfortunately, x does not have 2 other x's, so it's going to be the cube root of x. So it's going to be 2 times the cube root of x. So your answer is 8. Which expression is equivalent to the cube root of 27x cubed divided by 216 y to the 6th? What I did is I'm going to simplify 27 over 216, and you notice that the cube root of 27 over 216 is actually 1x cubed divided by 8 y to the 6th. We know the cube root of x cubed, it's just x, remember? X times x times x. So the cube root of x squared, x cubed is just x. The cube root of 8, remember 8 is 2 times 2 times 2. So the cube root of 8 is just simply 1, 2. So it's 2. And we know that we have 6 y's. So we have y times y times y, that's one group. Y times y times y, that's another group. So it's going to be y squared. So it's going to be x over 2y squared. So the answer is A. 57, we're going to state the number of rational roots. And we're also going to find the roots. What I'd like for you to do, because on the test, you're going to have to find the possible rational roots. And we did talk about this. It's going to be 40, 20, it's going to be 8, 5, 4, 2, 1. I want to say 40, 8 and 5, 20 and 4, 10. I think I was missing 10. 10. Remember, you have to find the ratio of the constant. In this case, the constant is 40 over the leading coefficient is 1. So if I divide 40 divided by 1, it's just going to be 40. So if I had to list them, once again, it'd be 40. The next one will be 20. The next one will be 10, 8, 5, 4, 2, 1. So now, before we do synthetic division, we're not that we're trying to do a shortcut, but we're going to use our tools here, and we're going to go ahead and graph this and see what's going on. So we have x to the power 4 minus 3x squared minus 40 okay, And it appears that there are we know actually two roots here. So I'm going to adjust the window. And I need to get out of here. I'm going to adjust the window, so I go to the window, settings. I just want to see how it's behaving. We have negative 20. Let's say 20. Y max, negative 20. And then we'll say 20 and see what's going on. Okay, it appears that it's at these 2 points. I'm going to go to the menu. I'm going to go to table. And I'm going to try to look for those zeros. I know that, okay, it looks, okay, so there's another way we can do this. Okay, menu, remove the table. I'm going to go ahead and press tab, and I'm going to press 0. And I've taught you all this, so we're going to look for the intersection. And let's see what type of 0 it is. If it's a fraction, yep, it is a fraction. Menu. So it's 2.82843. Okay, so I'm going to go ahead and stop. I noticed that these numbers they look like they're not integers. They're like they're numbers that have decimals. So I'm going to see if I can find them by factoring. Okay, so we know that x to the fourth minus 3x squared minus 40 is the same thing as saying x squared, and 40 have the factors of 8 and 5. So x squared minus 8 times 5 equals 0. X squared minus 8 times x squared plus 5. You notice that if we were to do the FOIL method, we would come back with x to the fourth minus 3x squared minus 40 equals 0. So now our next step is to let each factor, let each factor equal 0. And we're going to go ahead and use algebra here. We're going to just simply add 8 to both sides. So we have x squared equals 8, and then we're going to get the square root of both sides. So we have x equals plus or minus square root of 8. I taught you how to simplify this. This is actually the same thing as saying square root of 4 times square root of 2. So this is actually 2 square root of 2. So plus or minus 2 square root of 2. I'm going to move it a little bit to the left. Now the other one is interesting because you have x squared equals negative 5. Get the square root of both sides. So x equals plus or minus I times the square root of 5. Remember I told you this is a complex conjugate. It's a complex conjugate. Now it's interesting that we have 2.82843. Why don't we go back to our graphing calculator, to the calculate page, and let's type in 2 control square root of 2, and I'm interested as to what number we get. Oh yeah, we get that number, 2.82843. So this is an irrational 0. So on the test, you're going to have to find the possible rational roots. But in this case, I decided to factor. Just simply trial and error. I noticed that it was negative 40. So the factors of negative 40 are negative 8 and 5. This is a quadratic factor. So I let each quadratic factor equal to 0, and then I did solve for x, and this is irrational, plus or minus 2 square root of 2, which we did see here that these were irrational roots. We're gonna go ahead and state the number of possible rational roots. Remember that you have to find the possible rational roots. It's going to be the constant over the leading coefficient, the factors. We know the factors of 9 are going to be 9, 3, 1 divided by 1. So your factors are just 9, 3, and 1. We're going to use synthetic division to see if it's a possible 0. These are possible rational roots / zeros, right? So we're going to go ahead and try 3. So we're using synthetic division. We have x to the 4th, which is 1. Remember, we're missing x cubed minus 8, and then we're missing also x minus 9. And we're using synthetic division. We're using synthetic division. If the remainder is 0, then we know it's a root and we know it's a 0. So we're going to bring down the 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 8 plus 9 is 1. 3 times 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. So we have negative 9 plus 9 is 0. So we know that x equals 3. We know that x equals 3 is a possible root. And what we have now is we have x to the 3rd plus 3x squared plus x plus 3. Now what we're going to do is we're going to try, we have 3, we can try negative 3 if we want. So we have 1, 3, 1, 3, and we know it's a root. We know it's a root if the remainder is 0. Negative 3 times 1 is negative 3. 3 plus negative 3 is 0. Negative 3 times 0 is 0. 1 plus 0 is 1. Negative 3 times 1 is negative 3. So that's 0. So the remainder is 0. And like I said, if the remainder is 0, then we know it's a root. So we have x equals 3 as a root. We also have x equals negative 3 as a root. How many roots are we going to have? How many zeros we're going to have? We should have 4. So right now we have 3 and negative 3. We're going to try to find the last one. So we have x squared plus 0x plus 1 equals 0. So you have x squared plus 1 equals 0. And what I'm going to do is I'm just going to solve this algebraically. Subtract 1, subtract 1. So we have x squared equals negative 1. We get the square root of both sides. So we have x equals plus or minus I. And this is your complex conjugate. And they always come in pairs, a positive and a negative. So here's one root, here's the second root, and then you have plus and minus I, that's your third and fourth root. Now if you want to see this graphically, let's go ahead and I'm going to go ahead and graph this. So we have x to the 4th minus 8x squared minus 9. Enter. And you notice this is 1, 2, 3, negative 3. 1, 2, 3, that's positive 3. You can also see the zeros in the table. 3, 0. And then the other 0 is at negative 3, 0. And the other two are imaginary, so you're not going to be able to see them.